Welcome. In this video, we are going to discuss about the regression and correlation concepts. Moving further, regression analysis. Basically, it is a statistical method for analyzing a relationship between two or more variables. Okay, so when we try to analyze the relationship between two or more variables, we of course expect one variable to depend on the other or the other to depend on the one, and when we have more than two variables, of course we expect some dependency between these things. Okay, so here basically that is what we are going to analyze in such a manner that one can be predicted using the information about the others, right? And we make observations on different variables. With that observation we are going to establish some relationship between these variables. And here when we what we are going to do is that we start with an estimate of the population mean using some mathematical formula or a function, okay, which explains the relationship between the independent variables or the dependent variable. Okay, so basically we are going to do some mathematical calculations by for estimating the population mean. Okay, the function that we find is called as the regression model or regression function. Okay, initially we will start with a simple linear regression model which have only one independent variable and the relationship is linear. So when we say linear, of course we expect some expression of the form. Let me tell you, when we say linear we of course expect something of this form, right? Y equals a plus bx and x is considered to be the independent thing. So this is like when we say simple, we expect something of this form. And coming back, of course we have said that we have different observations on the variables, isn't it? So when we say different observations, we consider x to be the independent variable and y to depend on x. So basically and mathematically speaking, y is a function of x. Okay, so observations, so the observations can be experiments also. They are made and the values are x1 through xn and the corresponding values are y1 through yn, right? So now that we have a bivariate data, n different bivariate data, okay, and we wish to find out some curve of this form, and that curve should be the best choice relating the variables x and y. Okay, so when we say the best choice relating the variables, we expect it in the least square sense. Let us see what do we mean by the least square sense in the due course. And the next point itself is that, right? So we define the error to be yi minus f of xi. So see here, corresponding to x1, the data we have is y1. Okay, and this f of xi is what? It is identified from the curve that we have identified. Okay, so this value, this f of xi, is calculated from the function that we have identified. Okay, so we just take the difference and define that as an error. So basically this difference is what? Difference between the observed and the estimated value. And the total square error is sum of all the individual errors. Right? So in the method of least squares, we are trying to identify one such curve of this form, that is y equals f of x, such that this e is minimum. Okay, so to find this e, what are we going to do, and all the stuff we will see in the due course. The partial derivatives with respect to those parameters are equated to 0. And okay, so basically we expect the curve to be minimum, and of course in the function f some parameters would be present. So the partial derivative of this function with respect to those parameters are equated to 0, and by which we find some curve, and that is known as the best fitting curve. Okay, now that let us see the ideology of fitting a straight line. As I said, when we go for simple linear regression, we have y equals a plus bx, where a and b are the parameters which are to be determined, right? So if this is the case, then the error is defined as sum of yi minus a plus bxi the whole square. So this is the individual thing. And now, as said, we will have to differentiate this error term with partially with respect to a and b and equate them to 0. So when we make it, we end up in some equations, right? They are given here. So just try to differentiate this one with respect to a. This a, now it is a sum of terms, right? So when we try to differentiate this one with respect to a, what do we get? We get twice yi minus a plus bxi, and when we are differentiating with respect to a and we have a minus sign, so we'll have minus, isn't it? Right. So this is what we have. Okay, so twice of summation yi minus a plus bxi, and the minus is there. So you just take the summation inside and see what happens. It is summation yi. Okay, and this would be a minus times of summation a for n times, so it would become minus na, and this b is a constant, so we take it outside, so we'll have summation xi. Okay, and as a whole we have minus, so when we multiply that inside, we will have minus summation yi plus na plus b times of summation xi equals 0. So we just take the negative quantity to the other side, and that is how we get this first equation. In a similar way, if you differentiate this one with respect to b, in that case you will have something extra. Okay, so that is this xi would come out, and you will have to multiply this xi, and this minus also will be present when you differentiate it. So minus xi you will have to multiply everywhere, and you will take the negative quantity to the other side and have the remaining, there it is. Okay, so that is how you get the second equation, and these equations are known as normal equations. Okay, now from the given bivariate data, we can very well find out summation yi, summation xi, summation xi yi, and summation xi square. All this can be calculated from the given bivariate data. Once we substitute these data into these equations, now these two equations will become a system of two equations with two unknowns, namely a and b. Once you solve it, you can find out the values of a and b, and with which, if you substitute those values into this equation, you will get y equals a plus bx, like you will have some expression. Okay, and the best fitting line will pass through the point x bar comma y bar, where x bar and y bar are the sample mean, right, for the variable x as well as for the variable y. Now we have a problem here. We are asked to fit a straight line to the following data. X value is given and the corresponding y value is given. Okay, so when it is straight line, we wish to fit it in this form, y equals a plus bx, for which we have this normal equation, right? So this is the straight line that we are expecting, and the normal equation is this. So when you make sum of these entries, you will get the sum of entries in the first row, you will get summation xi, and when you make the sum in the second row, you will have summation yi. Just multiply the corresponding entries. 0 multiplied with 1, 1 multiplied with 1.8, 2 multiplied with 3.3, 3 multiplied with 4.5, and 4 multiplied with 6.3. That by that you will have the individual xi yi entries, and finally sum them up. So you will have this one as well. Just square the x quantities and sum them up, and you will have the summation xi square. Okay, so if we calculate here, we have the values as this. It is just a matter of substituting them in the normal equation, so we end up with something like this. And at this place, you are free to use any available technique to solve a system of two equations with two unknowns, and that gives you a value to be 0.72 and b value to be 1.33. When you substitute these two values in the required straight line equation, you get the line of best fit to be y equals 0.72 plus 1.33 times of x. Okay, so that is another problem concerning the same ideology. Here instead of x we have p, that is the difference. Okay, so when you write down your normal equation, instead of xi you will have pi everywhere, and accordingly the same calculations have to be carried out, and substitute them in the substitute them in the normal equations, and you end up with some equations of this form. Finally you will have to solve them to get the values of a and b, substitute them in the line of best fit, and you get this to be the line of best fit for this problem. Okay, let us continue our discussion on regression lines. So here basically we started with the assumption that x is an independent random variable which is deterministic, and y be some random variable which depends on this x. Okay, so s- to find the regression lines, scatter diagram is something that indicates the nature of a relationship. So basically x and y are there, so you can plot them in a graph, isn't it? When you plot them on a graph, you try to draw some lines. There can be any number of lines for the plotting that you make. Okay, and what to say, so there can be any number of lines, out of which one line would give you some better approximation of covering those points that we have marked on the graph. And that is a scatter diagram idea to find out the regression lines, which we are not going to cover in this video anyway. But still, when you plot the points, okay, that pair x comma y on the graph, that diagram indicates the nature of a relationship, which means whether it is in the increasing sense or in the decreasing sense, or it is not the linear at all, it is too non-linear. It, in most of the cases it may be slightly deviated from the linear, but still if it is too deviated from the linear, that also we can very well see from the scatter diagram. Okay, and for a simpler case, that is for a linear regression model, the relationship is of this form. Okay, y is alpha plus beta times of x plus some epsilon, where an alpha and beta are the regression coefficients, and this epsilon is the random error, and of course this beta is the slope of the regression line, right? So this is known as the regression line of y on x. So upon x, y is depending, right? So that is what. Okay, for this purpose, we make n observations, and through the n observations, through the method of least squares, we have seen how to find out the line, right? And here, the random errors are assumed to be normal variables with mean 0 and variance sigma square. All the random error, okay, so no matter how many random error we have, we expect everything to be normal variables with mean 0 and equal variance sigma square. Okay, so and using the bivariate data through the method of least squares, we estimate the coefficients alpha and beta. Till now we were discussing these constants as a and b, now it is alpha and beta. That's the difference. Okay, so a and b, in the previous case we have estimated a and b, right? So those are the estimates for alpha and beta, and these are unbiased estimators. Okay, because we have not given any special attention or special condition to be applied on a and b, that is why they are unbiased. Okay, since y is also a random variable, the relation obtained would look like this: y hat is a plus bx, where y hat is an estimate for the mean of y. Okay, so here what are the things? Once we have the data, we can find out the means that are denoted as x bar and y bar, and we have these following notation. This x is summation xi minus x bar whole square. So basically we are calculating the variance. Okay, not complete variance, we are doing something with the variance. Okay, so and similarly syy and sxy. Now once you have these quantities with which you can directly estimate a and b as b equals sxy upon sxx, and a is y bar minus bx bar. Okay, so here we have applied the method of least square through the normal equations. We estimated a and b. Okay, and this is an This is another technique through which also you can estimate A and B. Now we are moving into a concept called inference concerning regression coefficient beta. Okay, so this beta is the slope of the regression, right? So all the basic assumptions and the estimate for the variance sigma square. So we assumed the random error are normal variables with mean 0 and equal variance sigma square. Now that what would be the value of the sigma square, for which we have an estimate that is given as SE square is of this form. Okay, now the hypothesis test would be we expect the slope of the regression line to be something like this, for which we use the test statistic, that is B. This one we will have to estimate from the given data. This B naught, whether the beta is same as that of this B naught. This is what we are estimating, isn't it? Upon SE multiplied with under root SXX. And here also if you see we have n minus 2. So this is a t distribution with parameter n minus 2, right? So once you have this one, of course, when do we reject it? It is t absolute of t less than t alpha upon 2 is the region of acceptance. So of course the region of rejection would be absolute of t greater than t alpha upon 2. So with that we calculate the confidence interval for beta to be in this form, right? So moving further, here we have a data x and y is given, and the respective values are also given. We are asked to find the equation of a straight line which enable us to predict y in terms of x. So first of all we'll have to predict y. So for which what we are going to do is that we will make use of this idea. Okay, so we will calculate sxx, syy and sxy. So we will calculate that. Okay, for which we need all this data. We just calculate them. Okay, and substituting them in the respective formulas, we calculate the values. So using this, we calculate b and a values. So once we have this one, we have the regression equation as this. This was the first part of the question, right? In the second part, use the result in A to estimate the number of cars inspected by a person who has been working for 8 hours. Sorry, 8 weeks, right? So here number of weeks is given. So it is just a matter of substituting x equals 8 in the estimated thing. So when you substitute x equals 8, you would get 12.4438 plus 0.8977 times of 8. That happens to be 19.6286. We approximate this as 20 because the question is dealing with what? Estimate the number of cars. So the cars are generally positive integers. So that is why we approximate it to the nearest integer. The third part of the question tells us to test the hypothesis beta equals 1.2 against the alternate hypothesis beta smaller than 1.2 at 0.05 level of significance. And the fourth part of the question is to construct the confidence interval for the regression coefficient. So SE, we just substitute the calculated values into it and we get this value. Next, from which we'll need to calculate SE. SE square is there, from which we calculate SE. And the null hypothesis is beta equals 1 upon 2 against the alternate hypothesis beta less than. So we are going to make use of one tiled test. And we again substitute the values into the test statistic and we get minus 1.212. From the table, we observe T alpha to be 2.132. Now we will have to compare these two things, Tn minus T alpha, isn't it? So here we see that T is greater than minus T alpha, which means if you notice your absolute of T on the one side is lying in the acceptance region, therefore we accept the null hypothesis, right? In the fourth part, we are asked to find out the confidence interval. So this value is t alpha upon 2 is read from the table. SC is calculated, SXX is also calculated, B is known. So we just substitute them in the formula and we estimate the confidence interval for B. Okay. So we have another problem in which also we are asked to find out the best line. We'll have to fit it to the best line and we'll have to estimate the mean CPU time when x equals 3.5. So it is just a matter of substituting. Again, we have a null hypothesis to be tested against the given alternate hypothesis and we'll have to find out the confidence interval. So it is just all about calculating these things from the given data. So remember, xi and yi are directly read from the table. Okay, so in order to find these sums, if you just make the sum of the entries in the first row and second row respectively, you would get summation xi and summation yi. Whereas if you need to find out xi square and yi square and xi yi and all, you will have to square the terms individually and add it up. Okay, summation x y means you will have to multiply 1 and 2 separately, 2 and 5, then 3 and 4, then 4 and 9, 5 and 10. Multiply these quantities and write them separately, that is your xi yi, and add the results. Okay, so that is how we get all these things, right? Now we shall substitute them in the expression for b and a and we get it to be a to be 0 and b to be 2. So finally the expression is y equals 3x. When we substitute x equals 3.5, we get y to be equal to 7. And let us calculate SC through this formula and we find the test statistic value and we read the table value. We just compare these two things and we see that the calculated values in the acceptance region, therefore we accept the hypothesis. And to find the confidence interval, substitute the required values into it and we find the confidence interval. Okay, so till now we were discussing about the simple linear regression equation and test concerning the slope of the regression line. Okay, that's it for this video. In the next video we will discuss about the nonlinear curves.